Morning,
Hey,
everyone.
Brian.
Morning.
Awesome. So welcome everyone. This is the 28th of April, APAC timed. So Graham, you have the first item.
Thank you. So basically the only agenda item I really have is to go through, for those of you who haven't been following along or completely aware of the work I've been doing around trying to plan what we want to do with the GitLab com repo, which is the main repo that we use for deploying gitlab.com on Kubernetes. I've done two kind of bits of work recently. I've done a discussion issue that kind of highlights the problems, and then a document which we converted into epics and issues and things about what are the solutions, or what we can look at the solutions. So I'd like to just kind of briefly run through that. I'll share my screen. I'm going to be very sensitive to time here and try and kind of keep things as quick as I can. So the issue is in the meeting docs, if people are interested. So we've had a lot of different issues, like around specific problems we've had with the GitLab.com repository, and we've had a lot of issues about ideas for fixing that, but perhaps a little bit low level. So what I wanted to try and do with this issue is just pull back a little bit, take all those issues and kind of try and look at it more at a little bit of a high level, and try and give one kind of big overview picture of what all the problems are. Because what I found with a lot of the issues about specific problems, and what's a lot of the issues that we had about specific solutions, is there was a lot of duplication or slight duplication, or perhaps the issue or the problem was missing a bigger picture. So I kind of go through how things work at the moment. I've broken it down into a few different sections. So we have user experience problems, CI problems, repository problems, and auto deploy problems. I won't go through every single description here, but to give a quick overview, we have from the user experience problems, diffs on merge requests can often show unrelated changes that haven't been applied. Users outside of infrastructure, so infrastructure as a group, are unable to see the diff output. They're unable to see CI output. So because of the way we've got the security and the fact we have secrets in this repository, and then users outside of infrastructure who don't have access to our Kubernetes infrastructure, probably even people in, say backend engineers and delivery, are unable to get very simple picture of what is our Kubernetes deployment objects, what do they actually look like. CI problems, when master breaks on the repository, we get absolutely no notification that it happened beyond like an email saying a pipeline is broken, which is very easy to miss. Our CI pipelines are very bloated due to the fact that we can't make intelligent decisions around what jobs that we include. So for example, if I make a change to one cluster in pre, or even just one deployment in pre, we run every single job, deploy to production, deploy to staging and everything, because we just have no intelligence to say, okay, this is only a change for pre, GitLab CI only needs to run against pre. CI job is canceled while Helm is running. We have this Helm in an unclean state, which gets us a lot for delivery. Helm's detection of problems and rollback is very slow, if it works at all, and often gets us in a state of cleanup. So this is similar to the above. At the moment, if you're a release manager or anyone doing deployments, basically if something goes wrong, you probably won't know about it for at least an hour, if not 2 hours after the deploy actually happens, just simply because Helm will sit there for an hour, it will time out, and then it'll roll back, taking about an hour. So it's extremely slow and not the greatest experience. Pipeline execution time is very long due to some of the tool choices. Repository problems, we have no easily viewable ledger of changes and what order they happened in, because we push stuff through Git, but we also push a lot through just pure pipeline execution. In fact, pure pipeline execution just on ops.gitlab.net, right? So not even pipelines visible on .com. So it's these kind of, between those two, it's very hard to just get a clear picture of as to what happened when. Diff jobs showing actual changes and MRs can get stale, similar to the above. We can't do any static analysis or the preemptive validation of manifest and CI jobs. So a classic example is we recently had to spend a lot of effort going through all our Kubernetes objects for API depreciations because we were upgrading Kubernetes. They said we're going to get rid of these certain APIs, and we were using them, and so we had to go and find them all and stuff like that. There is a lot of tools, and in fact, I think GitLab itself, the product, ships a couple of these tools to actually audit your files in merge requests or in a CI pipeline and say, you know, this is using a deprecated API, or this is insecure, or, you know, container security scanning, all that stuff. And we cannot leverage that at the moment with our current setup. Tooling solution is poor in logging. So we've got some manual jobs to do some band-aids to make sure we don't pull dynamic data in from gitlab.com. So there's a couple of themes here. As you can see emerging, we do secrets management inside the repo. We pull data from Chef when there's no reason to. And now auto-deploy problems, which are probably the most interesting to us in delivery. Similar to the above, changes outside of auto-deploys can be left unapplied, or if a job breaks or anything, they basically will block us from doing auto-deploys. It's kind of by design, but it's not an ideal situation, right? Like ultimately it shouldn't be that way. It shouldn't be us to be like, something's happened and then us go and investigate and then find out we have to hassle someone else because, you know, they didn't do the change in the correct way or follow through with the change if it broke something. Auto deploy pipelines can interleave with configuration changes on a per cluster basis. So once again, all these pipelines can run. Auto deploy pipelines, merge request pipelines, everything can just run. And you know, sometimes if they're running at the same time, you get this kind of weird crossing of changes happening, or even just diffs, and trying to just understand who is trying to do what is incredibly difficult when that happens. It's not often, but it will continue to happen more and more as we speed up with our deployments and the amount of change. And the version of the components that is run is passed as CI variables, meaning we have no concrete history inside of the repository or when those components were changed. So once again, this is the Google Doc, which I'm starting to use to put together the solution. The reason I started with the Google Doc rather than actual issues is it's a lot easier to kind of edit, track changes, do suggestions in Google documents. But, you know, if there's a general agreement on the approach here, I do want to try and push this into epics and issues, and then further refinement and feedback from there from the team. This is kind of like a first pass, and the reason I want to present it here today, just once again, make people aware of it, spike conversation and feedback if necessary. So I've got 4 kind of key epics or things I've tried to identify as, at least to start with, the solutions to some of these problems. Some of them are very simple and straightforward. Some of them need more investigation and a bit more refinement. So I'm going to start with the easiest one and the simplest one, and then work my way through to the hardest one at the end. It might not be in order. I've ordered these on how I think they should be done in terms of we need to do this before this. But once again, that's not concrete. And as we kind of dig into this, it might become a little bit easier. That might change. So the first epic is really just about removing any external data sources from that repository. And what I mean by that is, for those of you who aren't very familiar with how the tooling runs in that repository, I kind of use an analogy like this. The code and everything we put in that repository, the way that we use a bit of bash, then in a tool called Helm file, which then runs Helm, which then like actually does the work on the cluster. What we commit to the repository is like the recipe to bake a cake. But the problem is a bunch of those ingredients that we put in are from external sources. They're from Chef, they're from, I think, variables. There's all sorts of different random things that we include in that. So what we try and do, for example, when we do an auto deploy, is we run a job to bake the cake with all of these stuff in, and then see if it's what we expect. And then when it's not, we just fail. So a release manager has to come along and be like, okay, the job has failed. And then there's a whole process about determining why that's failed. Is it a change from here? Is it a change from there? Is it someone hasn't applied a change? So it's very, it's very manual when that happens and error prone. And it's very frustrating. And if any of those external data sources go down, we fail our deploy, we fail everything, even if it's just a transient issue. So this first epic is just about removing all that. There will be no external data sources in the repository anymore. So there's a couple of things here. One, we pull data from Chef dynamically because there's certain settings for the GitLab application that are in environment variables. They should not be, and there's issues open to actually move them into the gitlab.rb and the GitLab YAML, so into actual file on disk configuration state, but they're not. So at the moment, we need to modify the upstream chart to allow us to set those settings from Kubernetes secret objects. So at the moment, they're literally put at runtime. So they're basically, we call out to Chef, even though they don't need to be in Chef, and then we pull them in, put them in an environment variable, and then ship it off to Kubernetes. The problem with that is obviously it's an external data source. And also because we consider these secret data, it's a big blocker, right? For us to be able to expose this, expose diff output or just expose more of the repository and what's going on to other people because it contains secret data. The second part is we actually do the secret. So all the secret data we do for GitLab.com is inside this repository. I made that call when I first set up this repository because I was big on the kind of mono repo approach and not fracturing things into different places. But when I made that call, I was an SRE and I didn't have as much overall view of the company as I did now, especially not delivery. So I missed that key point that me as an SRE, especially in reliability, could see everything. Permissions were never an issue. So it was a very easy decision to make. But obviously now, as we, auto deploys, delivery team members who don't necessarily have the permission, and ultimately, we want to open this up. The goal is to open this up to GitLab developers more and make the workflow easier for everyone. Having secrets in this repository is a huge barrier to us because we always have this consideration, oh, we can't do this or we can't do that because there's secrets here and the data classification for this is high. So therefore we are restricted in what we can do. There is no reason for that to be like that. It's a very simple task for us to take the snippets of code we have now that do the secrets management, put them in their own Git repo and just say, okay, that the permissions of that are locked down, only these people can see that. Most people, who are using this repository, including ourselves in delivery, don't really care that much about what's going on with the secrets. We rarely change them. So I think just pulling that out solves a huge problem. This one, actually, I might drop this point out. This is probably, I might strike through this. This is covered a little bit later. And then this one is just to check that if we remove all the external data sources, do we still need some of the cumbersome tooling we have around blocking access to the gitlab.com during CI runs? We might still need it and it might still be there, but I do think it's another task. So I said, all in all, this one should be relatively simple. I understand concretely what needs to be done. And, I personally don't think it's too controversial or anything is very unknown. Does anyone have any feedback or thoughts on that specific kind of overall goal?
Let's do it.
So the end result for that should be that the big thing will be that less breakages of auto deploys. There's less external sources, less breakage of auto deploys where it's like, oh, someone changed something in Chef or whatever. We just get rid of all that. It allows us, not straight away perhaps, but it paves the road for us to then, I want to drop the permissions from the CI accounts to actually look at secrets. So the CI accounts for that repo will not be able to look at secrets at all. And then we can actually do a better job about who can see the CI jobs, right? Because the big risk at the moment is no one can see the CI jobs. They might have secret data. If we make the repo safe and we make the CI the permissions that the CI repo has, like the service accounts and all that, if they just can't have permission to see the data, then it's a lot easier for us to open that up, and therefore, you know, a lot better user experience for people because they can see a little bit more what's going on. But that's kind of a future thing. And I think what would happen is we'd still do an audit and kind of figure out, you know, does that make sense and what other considerations?
Yeah, I'd suggest breaking that bit off, Graham, because I think it ties so tightly to our goals of helping teams get to self-serve. But before we can do that, we have so many other pieces like improving tooling and just generally a lot of other stuff. So I think it'd be good to get it as its own thing, but something which we maybe separate off from this sort of first phase of this at least.
Agreed. And I haven't included that part here. Like I have not, that's just me thinking out loud. This would pave the very concrete part. Our outcome here would just be less failures of auto deploys, but it does definitely pave that road. But I agree, that is a separate discussion that we'd probably do later. But it's certainly a first step towards that because it's the biggest step. Whenever we talk about trying to get people, you know, to view more and do more in that repo, the first thing that always comes up is, oh no, but it's got secret data and that's classified, you know, I think it's red status or whatever. So so the second kind of epic is, so that one's very easy and concrete. This is a little bit trickier, but I think still sensible. So what we want to do is we want to stop this interleaving of GitLab CI pipelines. So there's a lot of work we can do with CI pipelines for this repo, but in order for a clear, easy first iteration, I think just making it so that no two CI pipelines in that repo can run at once. So entire pipeline level locking. However, I thought about this and I'm not sure if there's use cases where we do want two CI pipelines to run at the same time. An example might be if we want to deploy to production and staging at the same time. So I think this epic is definitely a investigation of what are the use cases. If we just say no two CI pipelines for this repo can run at once, what are the bad things? What is that going to break? What are the use cases where that doesn't work? And then we refine from there what we can do. But it's really about increasing the locking.
I have a question about
Sure.
this because I've been thinking about this for a very long time. So first of all, just to clarify your point, are you thinking about resource group locking at CI level, or are you thinking about some external locking implemented somewhere else?
So I think we need to investigate all of these because I'm not entirely sure. I've put some avenues for investigation: merge trains, resource groups, global rock resources, some other things. But yeah, even just another tool or another something.
Okay, sorry. Someone is ringing on my doorbell. I'm sorry. Just come back soon.
So yeah, so basically to try and not just get stuck down in discussion on this issue, I'm trying to make it clear that, or at least start with the hypothesis that we only want one pipeline running in this repo at once. And then working backwards, is there any situation where that hypothesis would be bad? And you know, refining that hypothesis from there. I think even when I looked at the pipeline or auto deploy pipelines today, we still do not overlap production and staging deployments. So I still think this hypothesis is valid. And in which case, this epic is probably just a little bit of investigation, a little bit of implementation, and probably a lot of testing and rollout of that, and making sure that everything still works as expected. I really think merge trains from our product would be invaluable, but I realized today we have a very awkward problem with that because we do our merge requests in gitlab.com, but it's ops.gitlab.net that actually run the pipelines we care about, the ones that deploy. So I don't think we can, merge trains work within a single GitLab instance, like the whole workflow around them, some of the safety they give you, and the locking, they only work in the same GitLab instance. So if a merge request is in gitlab.com, I actually don't think we can use them in ops.gitlab.net. So this is why this is a little bit of an issue where we need to understand what the options are. If we go with the goal of repository level locking, What are the options and how do we make that work with both gitlab.com and ops.gitlab.net? And that's why I think there's a little bit more work here than just say a single issue. Okay, so I'm going to skip over to 4, just because I'm doing this in order of least complicated to most complicated. So modifying release tools and patcher, because we still use that, but both of these tools to no longer depend on CI variables. I've got this as number 4 as I think this should be done last, but it could be done in parallel. Actually, a lot of these probably could be done in parallel, or it's definitely a lot harder to see what is depending on what immediately. So what this covers is really more looking at release tools and patcher and seeing the model that we currently use to run auto deploys is we simply invoke an actual pipeline and we pass a variable in. This is the version we want to deploy. But trying to change that to a more descriptive model and changing the API. So at the moment, the API that release tools uses is running pipelines with these variables in, but that is very hard to read. In terms of like the history, you got to find the pipelines, you got to like, and even when you find the pipeline, you can't see what variables were passed in easily. It's a tricky kind of situation. And if we want to try and move to a pure GitOps model for this repository, which I'll get to soon, and I do think that's valid, then the interface for release tools or patcher or anything that wants to do deploy is not running a pipeline and passing dynamic variables in and then expecting a different outcome, but the same interface we expect our users to interface with the repo, which is through a merge request or pushing a commit straight to master. So we give release tools the permission to push commit straight to master. So it creates a commit saying, I'm going to change, this version of the image as a commit, pushes that onto the repo. A pipeline will run on master, which we can match to the commit that we created. So then we know exactly this pipeline is run by this commit, which was caused by release tools doing a deploy. Or alternatively, you can do a merge request, merge that, and it's the same thing. This is an idea. It may not be, there's probably a lot more to it, or there's probably a lot more problems to it than I initially.
Yeah, there is a big problem here, which is active pipeline waiting, which is something that we tried very hard to remove, and we only have it for things that are happening on dev. So there are a couple of things we can try here, which are interesting. One is a self-committing pipeline, where you are still invoking that pipeline. The pipeline is basically it receives the variable, it commits itself on the repo, and with some kind of skip CI, so that you don't trigger a real pipeline, because otherwise you can't run it. And then you trigger a pipeline on that new commit. Because if you trigger a pipeline as part of the pipeline, this is a child pipeline and can be tracked in waiting. So you can still wait for it. But if you're not doing something like this, basically you end up having double pipeline, and then you have the timeout problem, which is the same that now we have with staging graph, and that we have with tagging and package creation, that you commit something and then you have to actively wait for it to complete. And when do you stop? Sometimes you stop after 30 minutes and that pipeline takes 35. And so everything blocks.
Right. Yeah, I see what you're saying. So don't we have that same problem though with deployer at the moment? Because it runs a k8s workloads pipeline and it still active waits for it to complete, right?
Yeah, we have that problem there. We have that problem with tagging, but for instance, k8s workloads is, we never reached that point, but we were supposing to move it to release tools with proper triggering.
Yep, sure. Okay. So no, that makes sense. So this I might rewrite a little bit, because there's another direction or discussion that can happen here, is that, and I already had an idea / issue for this, and I think maybe this merges into it as well, is that we basically have release tools talking directly to Kubernetes. and just patching, doing a Kubernetes API request to patch the resource and change the image name instead. And then we just bypass CI, and release tools handles it. It like locks k8s workloads. We basically bypass k8s workloads. That's got its own pros and cons. So maybe I'm a bit too specific here, but I do think reevaluating the process that patcher and release tools currently work with this repo, I think is the overall kind of thing I'm trying to get with this one, I guess. And maybe I can rewrite this to be a little bit more generic in that, exploring what options we have of how release tools specifically does that. What I was hoping is that by using something like just pushing commits or a merge request to the repo, we just write the one pipeline for k8s workloads that can be used for auto deploys and everything. Everything just becomes the same workflow, and a configuration change or a deploy is still just a commit. It's still just a pipeline. And then we can do things like cluster targeting and everything based off the files that were changed in the commit or the merge request and things like that. So that's what I was kind of going for. But I do understand that that's different than triggering a downstream pipeline.
Before we maybe it would help then, can we frame this one in terms of what we actually want this to look like rather than what we necessarily have right now? Maybe let's think about from a release tools perspective, like what do we want release tools to be able to do? And then maybe from a sort of a, I think a question for me, I'm not super clear on is, as a SRE making changes, how does an SRE want to get their cluster changes out to production? I assume they don't want to wait on an auto deploy. So at that point, we have sort of two requirement needs of how changes reach production. And then we can maybe start to look at like, how do those things happen right now? And what options do we have to get closer to what we want?
Sure. Yeah, no, so it definitely wouldn't be, it would be the opposite. Auto deploy. So basically it's a unifying of the pipeline. At the moment, when you run a pipeline in k8s workloads, you can pass a variable, is this an auto deploy? And they do different things based off that. But what I'm trying to say is whether an SRE or anyone is changing a config item, or whether an auto deploy is changing the image that we're running, under the hood, there just changes lines of text for the deployments, right? So it's, can we unify the interface so that, honestly, using Git, just like you're just doing the Git commit, when you commit that, it has a pipeline that rolls that out, and therefore, release tools is creating a commit which creates a pipeline, or a human being is creating a commit which creates a pipeline, and it's just a unification of that idea. But as I said, there's probably a lot more that I haven't thought about that we need investigation and discussion. And this one kind of might link into how this works as well. This makes CI pipelines more isolated, because I think one of the options even with this is to do dynamic child pipelines. So actually, believe it or not, the GitLab documentation has they've done a lot of work since I last looked at this with dynamic child pipelines and stuff. It's not unreasonable for us to do dynamic child pipelines per environment as well, and things like that. So I do think there's a few more options there, but both 2 and 4 really just circle around how do we do CI in this repo that makes sense and is as simple as possible while giving us the safety and pieces we need.
I have a question with this, because I was making my point before, but then someone rang the doorbell, but you came back to the thing. So I'm really supportive of the dynamic child pipeline. Is something that I wanted to try myself. There is an open question to me here, which is, if we, and I don't think this is the defined in the documentation, but if we put a resource lock on the trigger of the dynamic child pipeline, will that lock extend? And it's a depending pipeline. Will that lock extend to the whole pipeline? Because if the answer is true, and we can get a QA smoke test confirming this in the product, then this is a great way for having isolation at environment level, which will give us more more parallelization in terms of what can we run on several different clusters.
Yeah, exactly. No, I agree. Yeah, absolutely. Okay, so then the last epic, which is kind of the biggest one. So it's basically the very short description of this is, once again, with my kind of very bad analogy, at the moment, this repo is very much about, we put the recipe to bake a cake, and then in CI, we actually run that recipe. We, we bake the cake. Does the cake look what I expect? What is the cake in production? How do we diff that? So there's always surprises that happen CI time, and kind of the common thoughts around that in the upstream community and how to do things is this model called GitOps, which or pure GitOps, which they call it, which is a little bit of a marketing term more than anything. But at the end of the day, what it means is that instead of just putting all these pieces in the repo on how to quote unquote bake the cake and then baking it at CI time, you actually change your tooling and workflow so that when you make a change in the repo, you more or less compile it and you get the actual manifest, so the actual output that's going to be run against the cluster, and you put that in the repo as well. So we do this for other repos, like the Runbooks repo is a classic example already. It's a fairly well-known model. So when you're putting a merge request up, you're not only putting the merge request up, oh, I changed this value for a Helm chart, or I changed this, you also change it, you're actually committing the output as well. So this cluster will change this file, this cluster will change this file. Then in CI, you validate that the person hasn't done the wrong thing. So you take their input, you confirm their output is the same, just as a pure validation. And so what that means is when people are testing locally, everything is there for them to see. I'm going to test this input. Oh, this has changed this output. I can confirm that locally, and I'm ready to push that up before I even do a merge request. Like before they do a merge request, there's no kind of development in CI. It's all happens locally. They can see the changes. It's a lot clearer. It's a lot more sensible. And then the merge request is always just, I've changed this source, and you can see the output here. CI validates that's correct. We no longer have to run diff jobs against actual clusters. So we can remove some of the permissions we need from that, making CI jobs a lot faster as well. Because any diff, like I've changed this, what is it changing on the output side, is there in the merge request. So it's very easy to validate. Use it from a user experience perspective, it makes it incredibly easy for anyone inside or even outside the company to say, what is the current value of the memory requests on the Git HTTPS deployment pod? It's right there in Git. They can search it. They can, it's just there. It's a very easy, obvious kind of process. So this would kind of be a bit of a shift, hopefully not too much. The other thing this kind of covers as well is our use of Helm. So Helm does three things for us. It does this whole templating and generation, so the kind of recipe and baking of the cake, if you use my terrible analogy. It actually does applying that stuff to the cluster, and then it does the monitoring that, the rollout was successful. It does an okay job at the first thing. It does a good job at the second thing, and it does a very poor job at the third thing. So by moving towards this kind of the manifester and the repo, we will still use Helm and the GitLab, because we have the GitLab Helm chart, to generate the manifest. It's always going to be there at some way. So we're going to use Helm, pass the Helm chart in, pass some values in, we get out the output. That's always going to be there. But if we don't use Helm to do the other stages, we are free to choose better tools and develop our own workflow, which I think could actually be a standard workflow that we could adopt as like a best practices or a standard that we use in terms of delivery for basically applying things to a cluster, Kubernetes cluster, rolling out a change, and then most importantly, determining if that change was successfully applied or not. So I mentioned it a little bit earlier. The way Helm works is that let's say we're doing an auto deploy, Helm applies it to the cluster. It will wait until all of the pods, are running the new version, which is fine. But if a pod is crashing, it'll just crash over and over. Helm just sits there saying, okay, I'm going to wait for the pods to finish crashing. And this is all by design because Kubernetes is about eventual consistency, not like you do a request, you get a valid response back straight away. But what it means is that if no one's watching, the CI job will just run, the pods will crash over and over for an hour. And then we have a timeout that says, okay, if it hasn't succeeded in an hour or whatever the value is, I think it's 2 hours, I don't know, then just roll it back, which is fine. So then it rolls it all back. But that means that unless you're sitting there watching the pipeline, like the output of the pipeline, you probably lose an hour before you even roll, well, 2 hours before the pipeline fails and you notice something is wrong. Fortunately, with the way we do Kubernetes rollouts and everything, it's very safe. We usually don't have incidents or, you know, anything going wrong from a customer perspective, but it's very slow. So by splitting this, Helm becomes a templating tool with the GitLab Helm chart for defining the manifests. We are now free to use different tools for applying them to cluster, which is a simple problem. We can just use kubectl. I don't see any reason to use anything different. And then we can come up with our own tooling solution or just use what's already available to monitor the rollout. And I think this is incredibly valuable because we can start with something simple that's probably better than what we have now. Excuse me, which could even just be a set of tests, a script. Is the pods crashing? You know, just very simple stuff. At the moment, we can use kubectl rollout status to give us like, you know, the output of number of pods that are changed. But over time, as we have probably as we have more incidents and find more problems we need to check for, we can expand that test suite, right? So we can actually start to say, okay, now we want to check the pods are valid. We may want to watch Prometheus metrics, right? Like we may want to say, okay, we've seen the pods already. We're going to watch them for 5 minutes to make sure there was no massive apdex drop or something like that. You know, all of that is now available to us because that's the stage we can define ourselves. And then what our rollback story is when we detect something goes wrong becomes something under our control as well, that we can do whatever we want. So once again, there's maybe not, there's good benefits straight away, but it does open up a lot more doors for us to make deployments safer. And I do genuinely believe we can develop some of these pieces with the ultimate goal of them becoming CI templates and part of the GitLab product. Because everyone wants to monitor their rollout of their Kubernetes deployments. These are generic problems.
I was also thinking that one of the extra benefit of this approach when you were describing is that it has a better disaster recovery approach here, because the diff assumes that the cluster is healthy because we are checking that only several things are changing. But if the cluster isn't healthy, you can't even restore it to the what is expected to be. While here, when we did the diff at the review time, and then we have written down in the repo the expected status, if we want to say, just bring the cluster back to this point in time, you don't care
just
about
apply
diff.
It. Yeah.
Just apply it.
Yeah, exactly. Yeah, exactly. Agreed. Which we can't, you're right, we can't do at the moment. If things are in a very bad state, we got no chance of actually getting our CI jobs to pass.
It also protects us from, I'll call it tooling shortage. So for any reason, there is a problem, a huge bug in Helm, whatever, that's preventing us to deploy. Here we have easier way to get out of it because we can still change that template files and just commit it, and kubectl will be there.
Yeah. And I think we can develop, you know, we can start doing what we do a lot more with like, at the moment we rely on CI variables again, which is okay, but I think we can do things like have labels on MRs. If you put a label skip k8s, if you have a label emergency, then maybe it will just like apply, like that's the only job, right? Like it just skips the rest of CI and just applies it and things like that. You know, we can do things like that. Or, you know, emergency might not validate that this was, you know, correctly changed. It will just like an emergency kind of apply. So I think we get a lot out of that. But yeah, I think the freedom there to define our own validation of rollout, I think is very, very, I think is going to become more important, because I don't think it's very well known, because it doesn't cause customer facing incidents, that when something goes wrong, our mean time to detecting that change and fixing it is actually incredibly slow at the moment, and it shouldn't be.
So I have a counter proposal to this,
Sure.
which is, I mean, it's even harder to implement, but what about a GitLab.com operator? Because what it looks like here to me is that we just want to change variables, versions. So there are something that we want to control, like the versions or some configuration options. And then what you define as we want to build our own rollout checking strategy sounds more like I
Like
want to have
operator.
something in the, an operator in the cluster that is making sure that the system converge to what is expected, and it alerts if it's not converging and things like that.
I agree. I think that is the ultimate long-term goal. Not sure if we can get it away as a first step, but I
Sure.
agree. I
think, obviously.
Yeah, you know, this is kind of like, at least this might be a first step, but I 100% agree. That's where we need to go for those reasons, as you said. Like,
because it has some nice benefits if you want to do ephemeral environments, because once you have something like this, you can say, I need a new environment, and it would just create it for you, right? Because it handles a GitLab.com style type of deployment.
Yep, we can, you know, it's useful for the green if we want to, you know, if when the platform team starts looking at blue green, you know, it's invaluable for that. I think it solves the auto deploys for Helm charts issue, because the Helm chart becomes in the operator, and therefore if we're auto deploying the operator, we can get the Helm chart in there. And so I agree, that is definitely something we should look at and do. It's really just a question. I'm happy to look at that now if we think we can do that now. I'm not sure if we can
it's just more let's
that.
keep this in mind when we make decision.
Absolutely.
Right, this is something that is an important goal, but not right now.
So in interest of time, since we are now at time for this meeting, next steps. So Alessio, like, do you want to join in on this document, or do you think that your comments are kind of and that gives us an easy way to edit things? Or do you feel happy enough that we have good enough stuff to go to issues and epics and then input into that?
I think I can input into that because I was basically in line with everything Grames was suggesting, just was making remarks and things. So it's fine.
Great.
I don't think there's like as I said, I'll freely admit these aren't so like there's not a solution, you know, like there's further refinement needs done, but I do think we're at the point where I think doing it on the issue where the conversation is recorded there now. It was really just a case of, is there anything major that needs to change? Or I did rewrite some stuff, but I think now we can kind of
start. Like, I mean, if you focus the issues and epics on like really capturing the problem and the sort of result we want to get to, then I think the actual how we get there, the implementation details, we can figure out as we go. I don't think we have to have that all locked in right now.
Yeah, it makes sense.
Awesome. Thank you so much for going through that, Graham. And thanks for all the thinking you've been doing onto that. Like, I hope everyone appreciates that, like, this is this has not been a trivial problem to pull apart. So yeah, great to have a sort of direction for this. We are at time, but was there anything else anyone urgently did want to go through today? No? Okay, in which case, thank you all for discussions. Have a great rest of your Thursday. Take care.